Okay, so I want to take some time to talk to you about the metric system, and I want to kind of explain why I always say that it is the preferred system over the imperial system, non-metric measurement. So the imperial system is like feet, inches, miles, cups, gallons, that kind of thing. So why do I think that that kind of measurement is stupid and the metric system is better? So start by getting a new blank page in your notebook, title it metric conversions, and then make sure you also put that in the table of contents in your notebook as well, just like we do with all notes. I'm going to try to go through this presentation kind of quickly. Just make sure that you pause it as you need to. You should also know that most things in this presentation are not things that you necessarily need to write down. It's just mostly to get you some information and to explain why we use the metric system in science. So here we go. So the imperial system, I don't have my tools, do I? Do I have my tools? Yes, I do. Perfect. The imperial system is based on outdated standards of measurement that can have considerable variation. We'll look at proof of that in a minute. And the metric system is based on measurable, consistent aspects of our world. So that's why we like to use it in science, because it's measurable, it's consistent, and science is generally a study of our world. So we like to use a system that is based on that. So let's take a look at these units here. These are air pressure units. As you guys probably know, car tires need a certain amount of pressure in them to operate safely. 29 psi is a relatively common air pressure that's needed. 29 psi is equivalent to 2 bar. Let's look at the definitions of both of those. So psi is the imperial unit. That's pounds per square inch. So pounds and inches are imperial units. So the definition for 29 psi, I'll try to read this in one breath here. Ready? 29 psi exceeds atmospheric pressure by 29 times the weight of 7,000 grains of wheat spread over a square area the length of 3 grains of sound-ripe barley being taken out of the middle of the ear, well dried, and laid end to end in a row. I don't know about you, but to me that definition is absolutely bonkers. Versus the definition for 2 bar is exceeds atmospheric pressure by twice the pressure of the atmosphere. 2 bar. Okay. 1 bar is our everyday air pressure that we live in. We're under a certain amount of air pressure just on the surface of the earth. You guys might know, if you've ever been up in an airplane, especially if that airplane isn't sealed very well, sometimes your ears might pop. Or if you go in the mountains and you're going up and down big hills or mountains or whatever, your ears pop because the air pressure around you is changing. As we're at the surface of the earth versus if we're up high, we have different amounts of pressure. So anyway, 2 bar exceeds atmospheric pressure, which is defined at sea level, by twice the pressure of the atmosphere. So twice the air pressure at sea level. Much more basic than this whole thing about grains of barley and rice, or not rice, but barley and wheat and everything. Another justification for why we use the metric system is that most of the world uses it. This is one thing that I do want you to write down, is that most of the world uses the metric system. So one thing I want you to write in your notes is most of the world uses the metric system. Okay. Looking at this map, everywhere in blue uses the metric system as their primary system of measurement, and everywhere in red uses the imperial system as their primary system. So the US, obviously, this is Liberia, I'm pretty sure, down here, and this one I'm pretty sure is Myanmar. So 2 little countries and a giant world power use the imperial system. Kind of dumb. The rest of the world uses metric. Why don't we use it here in the US? I don't know why. The green, everyone asks, crazy messed up system where they call themselves metric, blah, blah, blah. That's just a joke for people who live in the UK. But anyway, so make sure one thing you write in your notes is most of the world uses the metric system. So this little visualization just kind of explains again, if we weren't using the metric system, if we had to use imperial in the science lab, these are things that you would have to memorize or have written down somewhere so that you could remember how to convert between pints and gallons and quarts and cups and quarts and quarts and pints and cups and gallons and everything else. You would need to memorize all these crazy numbers. 4 cups in a quart, 4 quarts in a gallon, 8 pints in a gallon, 16 cups in a gallon, 2 pints in 1 quart, 48 teaspoons in 1 cup, 16 tablespoons in 1 cup, 3 teaspoons in a tablespoon. I'm not going to make you memorize all that crap. What I do want you to know, though, is that there are 1,000 milliliters in 1 liter. If I were you, I would much rather learn this than all this, right? Metric system is way simpler. I won't talk too much about this page. If you want to look at some examples of stupid imperial units, actually, I guess you can't get to this link. I don't know, maybe I'll leave that link somewhere for you. If you want to ask me for it, but it's just a Wikipedia page with a bunch of stupid, outdated units. And then this is just a visualization. If you ever work with your hands, if you do anything with tools, for me, when I was your age, I was always working on my bicycle out in the garage. These days, I work on my car, that kind of thing. You might be familiar with tools that use these sorts of units. So for instance, if I'm using a 3/16 wrench, but it's a little bit too big, I would need to, in my head, think, okay, what's a little bit smaller than 3/16? Well, 2/16 is a little bit smaller, but 2/16 isn't an option. So how do I reduce 2/16? Well, I divide 2 by 2, so that's 1, and then divide 16 by 2, and that's 8, so 1/8. Okay, there's the step down that I maybe will need. Okay, rather than doing all that math in your head, if we just used the metric system, if I'm using a 5 mil socket and it's a little bit too big, maybe I'll step down to a 4 mil socket and try that out. Or maybe I'll step down to a 3.5. So it's just much simpler. You don't have to do any division. You don't have to do fractions. You really don't have to do math. All you have to know is how to count, and you can figure out your way up and down the sizes of a standard socket set. So again, don't bother writing this down. This is just some examples of numbers that, again, if we were using this in science, you would need to have this all written down or memorized. All these different crazy numbers that you would need to know. Versus the metric system, where we use basically things that are divisible by 10. All just 1 and 1,000, 1 and 1,000, 1 and 10, etc. Okay, these are much simpler than all this, at least in my opinion. And I think many of you will agree, this seems way simpler than this. Maybe you're more familiar with feet and miles, but to convert from meters and kilometers is way simpler. I'm honestly going to skip past this stuff. This is stuff that I talk more about at later times. You can do some research into the metric system if you want to learn the origins of the meter. But something kind of neat, just brief story, is that, well, I'm going to skip that too. Next thing I need you to do today is take a look at the video that I have posted below this in Canvas. It's a video where you're taking some notes on how to do metric conversions. So go ahead and watch that video, take those notes. I highly, highly, highly recommend that you write down everything from that video that I write down. Okay, it's really going to help you moving forward through these next couple of units. Okay, so write that down, and then the following video after that, so the third video in Canvas, is example problems. I bet the majority of you are going to benefit from watching those example problems. Okay, so watch those problems. Again, just like in this video, if you want to fast forward, if you want to pause, if you need to rewind, do it. Okay, that's the advantage of having Miss Richard in video form. You can't pause real life, Miss Richard. You can pause and fast forward video, Miss Richard, right? So go ahead and get started on the notes, then do the practice problems, and then you've got that quizzes to get some practice, all right? Good luck.